that's about all. Today we're going to graph points again. We're going to look at data in a table of values in just a different setting. So yesterday we had all of our points given in ordered pairs. Ordered pairs look like this: a bracket, then an X value, then a Y value. That's what an ordered pair looks like. The X tells you if you're going left or right. Y tells you if you're going up or down. Positive to the right or up, negatives went down and to the left. Ordered pairs is how we do most of our work, all right, just for the record. So moving forward after grade 9, typically ordered pairs is what's going on. However, there are other ways to describe data that you could then put on a Cartesian plane. And one of those ways is using a table of values. So a table of values is this guy right here. It's a table of values. It's like a little T-chart. Sometimes when I draw them, you'll see them drawn just like this. Like a little chart. And what this does is it shows you your ordered pairs in a different way. So when you're looking at a table of values, whatever beside each other, that's your ordered pair. So your first ordered pair would be a -7, -2. That means your second ordered pair would be at -2 and 3. And your third one would be at 1, x. Right, that's all table is doing. It's showing you your ordered pairs, but in a different manner. We're going to plot all those. So we did these things yesterday. We'll do the blue first. -7 means 7 left. Negative means 2 down. You should have a point right there. The green one is -2 and 3. So if you go 2 to the left and then 3 up, 2 to the left, 3 up, you get this guy right here. And the red one was 1, 6. That means 1 to the right, 6 up. You get a point right there. Awesome. If you notice, these 3 points actually make a nice straight line if you were to connect the dots. And they go right through like that. When we're drawing straight lines on graphs, which you're going to have to do, and you're going to have to draw things, it's important that you use a ruler. Don't just try to wing it and be like, oh, that's straight enough. If you don't have a ruler, use the flat edge of something else. So for instance, your calculators usually have a pretty good flat edge. So a calculator like this one, make that top is a perfectly flat edge. So I can put it on there to connect the dots. If you have one with a battery that pops off, usually that's a really good flat edge too. Or just bring a ruler so you can draw straight lines as well. I'm going to draw a straight line through this. My straight line would look like this. You're going to have to bear with me as I try to do this without a ruler. About as good as it gets. Right? Actually, I think I just figured something. Look at that. Did that show up? Dang, that's impressive. I wish I could do that on paper for you. Just have an auto straight line tool. Cool, we're gonna do that with the second one as well. So we're gonna plot those points. Actually, I want you to try to plot the points and then you try to draw the line. So try to draw all 3 points on your graph and then try to connect dots in a nice straight line. If they don't make a straight line, double check all your points to make sure you're in the right spot. Okay, so I've graphed all 3 of those points. And I made this nice straight line like that. It should make a straight line. And so if you're not getting a straight line, it's because one of your points is off. And you're just messing up something very small. So you need to just double check all your points. You'll notice that my lines typically will extend the entire page. Don't just go from one point to the other point. And we're pretending that this is one massive line segment that goes forever. And then we would even put arrows on the end of it typically, like this. And what those tell us is a graph is going on forever. That pattern would be going forever and ever and ever. That's typically how we'll write our lines. If it's a line segment, so that means it doesn't go on forever, then we would stop it. But we're just pretending these things go forever. Cool. Did you guys do stuff like that here? Plot points, connect them, make lines? Yeah. Some of you no. Okay. We're going to go down to here. So, lines like we just had can also be expressed as equations, which we'll get to. So if you look up here, like I could do a mathematical equation to create each one of these lines. It would be y equals something, and the other one would be y equals something as well. And what that does, it tells us the relationship between every point on this line. So for any x value that I chose, I can figure out the y value by using that equation. We're going to try using that equation, some equation right now. So this is an equation. It's in y equals form. That's what we're going to call it for now. We have a y value and an x value. The x value is called the input. The y value is called the output. Okay, so this is my input. This is my output. The reason I know that is because y is by itself, where x numbers all the same. To figure out your output value, you have to give your equation an input value. So for instance, if we pretended that our input value was -1, then what you do is you go to your equation, you write it out, but you change x to be -1. And when we change values to be what we want them to be, we use brackets. So when I put value in for x, I put brackets around it. It's kind of our unwritten rule for when you substitute things. You put brackets when you substitute a value. So I took my equation, I changed x to be -1. I tried to do it in red, so it kind of stuck out. And then what you'll notice is that you'll have y equals an actual mathematical statement that you could calculate. I actually calculate -1 plus 4. And if I did that, I would end up getting y equals 3. That means when x equals -1, y equals 3. And that would be an ordered pair on my graph. It'd be an input that has an output. We'll do a few more together. So pretend we have a line and we want to figure out where a point is when x equals 0. That's the next one on our line. Yeah, we can't see it. You can't see it? Do you want to move closer? Or do I need to zoom in? That help? Okay. So we're going to pretend that x equals 0. We're going to go to our equation and we're going to change x to be 0. Our equation is y equals x, which I'm going to change to be 0 plus 4. So I changed my input value to be 0. Now I can actually calculate what my output would be. Because I don't have an x value anymore, I have a number for x. So I can actually calculate this. When I do that, I get y equals 4. That means my output value is 4 when my input value is 0. We'll try it again. So we're going to pretend we have an input value of 1. X equals 1. We're going to put that into our equation. So we're going to change x to be 1. That would give me y equals, I put bracket on my 1, and everything else stays the same. I try to really color code my algebra so that you can see it. So things that I change, I typically do in red. Things that I don't change stay in black. So you'll notice the only thing that changed here was the value of x. Then I put this in my calculator. I go 1 plus 4, I get my y value of 5. The last one here, x equals 2. So I'm going to change x to 2. Everything else stays the same. You now calculate your output. So 2 plus 4 is 6. So my output is 6. And what I've done is I've found ordered pairs that I could graph if I wanted to create a straight line and figure out more ordered pairs on that graph or that equation. So these are all ordered pairs. I'm going to fill out the table of values to the right of it. So that means I have when x equals 0, y equals 4. That would be a point on my graph. When x equals 1, y equals 5. That would be a point on my graph. And when x equals 2, y equals 6. And that would be another point on my graph. And if you graph those, you would notice that you're creating a straight line pattern, just like we had in the last example. And that straight line pattern would be this equation from right here. So all three things kind of link together. You have the picture, you have the data, like the ordered pairs with the table values, and you have the equation. And all three things mean kind of the same thing. They all represent the same thing. We'll try another one. So I'll give you a minute. I want you to try to substitute those values in for x. I'll give you the first one, just in case. So the first one is x equals -1. That means I'm going to go to my equation, and I'm going to change x to be -1. Everything else is going to stay the same. And it's really important that I put brackets when I change x to be a value. So that should be your first step. The reason those brackets are so important is because this means 3 times -1. This does not mean 3 minus 1. So the brackets make a massive difference in these questions. 3 times -1 is -3. Minus 5 is -8. So we have a y value of -8. Meaning that's my output when my input is -1. Now try the next 3 on your own. Make sure to substitute properly using brackets, and then to do the calculation. If you need to use a calculator, that's fine. On the board, substituted in the red all my x values, and then I've calculated my y values. These are inputs and outputs, so I could create a table of values from these things. You might have already done this, but the first one is -1, -8. That means that's a point on a graph. I have 0 and -5. That's another point on a graph. That's a 1 and a -2. That's another point on the graph. And that's 2 and 1. That's another point on the graph. And if I had a graph, I could plot those points, and I would notice that I'm making a straight line pattern. And that straight line pattern is this equation. Right? They all link together. We're going to try another one. This one has a -2 in front of the x, so that's going to change things a little bit as well. The steps for substituting in are the same, so I'm going to change x by using brackets to be -1, like that. And so I write the exact equation, I just change the x value. What this means, this is -2 times -1 plus 3. -2 times -1, negative times a negative becomes a +2, plus 3 is 5. That means my y value for that equation is 5. So I now have a point for my graph. I have -1, 5. The next one, if I substituted it in, would be -2 times 0 plus 3. Negative 2 times 0 is 0. Plus 3 is 3. So I now have a second point on my graph, 0, comma 3. If I put an input value of 1 in, negative 2 times 1 is negative 2, plus 3 becomes positive 1. This gives me points of 0, 3, 1, and 1. Awesome. We're going to try one with fractions. We're going to try two with fractions, actually. So we got D here. We're just going to do negative 1, 0, and 1 as our D values for this one. And then we'll try something different for E. So we're going to substitute negative 1 in. When we substitute, you only change the x value. So if you're looking at your equation, your x value is actually on the top of a fraction. Everything else remains the same. So again, I'm trying to make that very explicit that I'm changing it and just the x value I'm changing. You could then put that in your calculator if you wanted. If you did, you have negative 1 divided by 2. That's what a fraction is. That's 0.5. And then plus 3 as a decimal, you would get y equals 2.5. Make sure you have that negative on the 1. That'll make a big difference. If we try the second one, we have x equals 0. So we're going to go to our equation. Everything stays the same, except I'm changing my input value to be 0. This means I now have 0 divided by 2. That's still 0. Plus 3 is 3. So my y value is 3. My third one, I have x equals 1. So I go back to my original equation. I'm changing x to be 1. If you your calculator 1 divided by 2 is 0.5, I add 3 to that, I get 3.5. Awesome. Again, these input output are points on a graph. So I could write them as a table of values as well, just to nicely organize my points if I wanted to graph. Last one. I think because some people already did negative 1, 0, 1, maybe we'll leave it like that. Did some people already do that? Yeah. Okay, I'll leave it as that, just to be nice. So we'll go negative 1, 0, and 1 as our input values. You could put anything, right? I could put 2, 4, 6. And what we could do is we could just calculate different inputs and different outputs. I could use any input I want. And it would give me some sort of output and then give me a point on a graph. We're just using negative 1, 0, and 1 because they're kind of easy numbers to calculate. That's why we're using those numbers. You go back to your equation. You're going to change x to be negative 1. Everything else needs to stay the same. So you now have something like that. What this is saying, this is 2 times negative 1 divided by 3. So I could put that in my calculator. 2 times negative 1 divided by 3. And it would be negative 0.66666. And then I would minus 4 from that. Yep. For sure. And you would get negative 4.6 repeated. So that means when my input is negative 1, my output is negative 4.6 repeated.
How would you graph that?
I would recognize that 0.6 repeated is 2/3. So when I'm graphing it, I would try to go 2/3 past 6 or 4, and it would just be a rough guess. Yeah, you wouldn't perfectly get it. You wouldn't probably be asked to graph something like that. Usually we get whole numbers, sometimes half numbers, because it's pretty easy to figure out where half is. But those odd ones, too hard, unless they gave you decimal points to graph. That means my x is -1, my y is -4.6 repeated. If we try with this next one, x equals 0. So I have 2 times 0 divided by 3 minus 4. If I put that in my calculator, 2 times 0 is 0. 0 divided by 3 is 0. Minus 4 is -4. So -4 would be my output value for my input value of 0. My last one, I have 1. So I'm going to put that in. Y equals 2 times 1 divided by 3 minus 4. You put it in using your calculator. 2 times 1 is 2. Divided by 3 is 0.6666. So it's 0.6 repeated. Minus 4 is going to give you -3.3 repeated. That's what you should get. Did people put that in their calculator and they got that? Oh, good. And again, these match up to points on a graph, which then you could connect to create a line, like we did in the very first example. Yes, sir.
If it's 2 divided by 3, it's 0.666. Then why is it 8.3?
That's a good question. Because we subtracted 4, what I did in my head was I had 2 over 3 minus, and instead of 4, I did a fraction. So I changed 4 into a fraction. I changed it into 12 over 3. Like that. And then I could subtract these to get -10 over 3. And then 3 goes into 10, 3, 6, 9. It goes in 3 whole times, and I'm left with 1/3. So that's why I'm left with a 0.333. It's weird, right? Yeah. So, for sure. Okay. We are going to try to graph these. So we're going to go back to A. We created this nice table of values for A. This table of values represents this line right here, or this equation. So we're going to go and we're going to graph these points. We're going to graph -1, 3, 0, 4, 1, 5, and 2, 6. So we're going to go graph those points. -1, 3 would be right there. Zero, 4, 1, 5, 2, 6. Here's 4 of them, right? I got all 4? Perfect. Once you label those 4 points, you could create a nice straight line to connect them. And your straight line should look like this. And ideally, we put arrows on the end because those graphs or that line could go forever. All right, we're going to talk about this graph for a little bit. So I want everybody to get that line on their page. If you need to take your time, thoughts, that's fine. Take a minute, and then we're going to talk about what this line represents. Everybody should have that line. If you're on other lines, that's fine. Just stop for now so we can talk about what this line is. Those blue dots that we have came from me getting my input values and my output values. The red line came from me connecting the dots. That red line represents the equation that created those dots, which I believe was x plus 4. That line is that equation. Which what that means is if I said, hey, what does an input value of 5 give you? Instead of having to go and mathematically do it like we just did, you could look at your graph. You could say, where on this graph do I have an input value, an x value of 5? So where on that graph do you have a point where x equals 5? And if you looked up here, that spot right there would have an input value of 5 and an output value of 9. That means 5, 9 would be another point on my graph. It'd be another input and another output value for this equation. I keep doing that. So I can say, hey, what if I had an input value of -5? Input value means x. X is -5 is right here. Where on my red graph do I have an x value of -5? Well, at that spot, which is at -1. And I could do this forever. I could figure out any point I want. I could figure out decimal points. I could do all of that. Yeah, for sure.
Mr. K, then what's the lowest on there?
It goes to infinite. Just keeps
on that graph right now, what is the lowest point then?
It's -10 and -6. You could reverse it too. So typically you get given an input, but technically you could get output as well. So you could say, hey, where do I have an output value of -5? Well, output is y value. Y is -5 down here. So it would be this spot on the graph that would have an output of -5. And that would have an input of 9. Yep. For sure. And then as you get better and better at math, and we'll do some of it later this unit, you'll start having word problems where this stuff becomes applicable. So a lot of things that happen in the world create straight patterns, where it's like a 1-to-1 ratio or something like that. For instance, like money you spend on bills or something, or money you're paying with savings account. That creates a linear pattern, which you then could just look at a graph and read that graph to figure out what your x and your y are. How long it would take to save this much money? When did I spend this? And so on and so forth. But it all comes from being able to take a graph, plot the points, connect the dots, and understand that all three things are related. We're going to try it for the next one. So our next equation, can someone just read me the equation for B? It was y equals 3x minus 5. Okay. So if you did that, you plot the point, you should have points here. Did we do 4 on that one? We did, didn't we? We did those. You should get 4 plots, which again makes a nice straight line. Whoa. One, 2, 3 over 2, 3, 4, 1, 2, 3. Should look like this. And again, you put arrows on your line. That tells you that line goes forever. Just because our graph stopped doesn't mean our line stopped. And again, I could read this line to give you more points on it. So if I wanted to know, hey, what happens when x equals 4? Instead of mathematically doing the algebra, calculate it, I could look at my graph and say x is 4 here. That means if I was to go straight up, I would get to my line, which is there. And I would get a point of 4, 7. And I could do that over and over and over again for y values and for x values. Awesome. I want you to graph the next two, just so you practice graphing. I'll show you what the lines look like so you can see if you're right or wrong, and then we'll move on. Okay. We're going to try a few more, like this one right here. So we have an equation given to us. And we're going to put some inputs in to get some outputs. The difference between these equations and the previous equations is that the previous equations were all in a form that we call y equals. It's y equals, and then all your numbers and letters and everything else. This equation's not in that form. Before we start doing any math and putting input values and output values, we want to change our form to be y equals form because it makes things much, much easier. Also, it's a skill you're going to need for the rest of math in high school. So to convert something into y equals form, you're trying to get y by itself. To get y by itself means to get y on one side of the equal sign, everything else on the other side. If you notice, your y is on the left side of the equal sign now. So my goal is to move everything to the other side of the equal sign. The 6 is already over there. The x, though, needs to be moved. And the way that we move things in math is with opposite operations. Have you guys heard that term before? Opposite operation. It means you want to do the reverse of whatever's happening. So if you look, this x is currently a positive x. It's like plus x plus y. So the opposite of having a positive x would be having subtract x. So we would subtract x from one side and subtract x from the other side. That's how you move something from one side to the other. So on the left, it cancels. X minus x is nothing. And I'm left with only the letter y. The equal sign is still in the same spot. On the right-hand side, I still have 6. And now I have minus x with it. That means my equation is y equals 6 minus x. That's what it looks like in y equals form. For the record, addition and subtraction can be reordered. So typically, people will put x value first. So you could also write it like this. Y equals negative x plus 6. That's the same thing. It's just rearranged. If you can do the first way, I'm happy. So if you can move something over and then rewrite the equation, I'm happy. If you want to take it one step further, write it like this, cool. Now I can do input values and output values very easily. So when x equals, we'll do 1, 2, and 3. 1, 2, 3. Y would equal 6 minus 1 is 5. 6 minus 2 is 4. 6 minus 3 is 3. And I now have 3 different ordered pairs that represent this line of x plus y equals 6. Rearrange, Then do your inputs, outputs. If we were to graph this thing, 1 comma 5 is here, 2 comma 4 is here, 3 comma 3 is here. I could connect those using a nice straight line. It would look like this. And don't forget your arrows fast. That line represents x plus y equals 6. It also represents y equals 6 minus x. Those are the same thing, just different forms. Yes, sir. Yes, sir. We'll try another one. So I have x equals negative y, x minus y equals 4. I want to get y by itself. So I need to move that x from one side to the other. It doesn't say it, but it is technically a positive x. So that's plus x minus a y. We do opposite operations to move that x. The opposite of plus x is minus x. We're going to subtract x from both sides. That means the x cancel out. On the left-hand side, I still have negative y equals 4, and then minus x is now there. Right? We've moved it to the other side. This is an equation that gets a lot of people in trouble in Math 10 and Math 11 because they get that answer and they leave that as their answer. And that technically is not y by itself. The reason it's not y by itself is because of this negative symbol right here. That negative symbol technically means negative 1 times y. Right? That's what it means. There's an invisible 1 there. So we want to get rid of that negative 1 times y. The opposite of timesing is dividing. So what we do is we divide everything by negative 1. And we have to do it to everything. That's the trickiest one, for sure. So if there's a negative symbol, that means negative 1. You need to divide negative 1. Those negative ones on the y will now cancel, leaving you with just y on the left-hand side. That's what we wanted. Equals 4 divided by negative 1. If you put that in your calculator, is negative 4. Yeah, my computer glitches sometimes. Negative x divided by negative 1. That's like a negative 1x. So if you had negative 1x divided by negative 1, those negatives would become a positive x. This equation rearranges to be y equals negative 4 plus x. Okay, that's a hard one. I have some advice for you. This is algebra, right? Algebra is you have an equation and you're moving things around. When doing algebra, do one thing at a time, write out the one thing you're doing, and then always reorganize your work. And then do one more thing at a time, and then always reorganize your work. The algebra that you're going to be doing this year isn't that crazy. You might be able to do it in your head sometimes. But the algebra you're going to do next year or the year after that, you'll no longer be able to do in your head. And those of us who practice the basics of algebra do fine in grade 11. Those of us who just see it and do it in our heads, you do so poorly once the equations get too hard. So practice the basics. Move one thing, show your work, reorganize. Move one thing, show your work, reorganize. And just follow that pattern until you get whatever you're trying to do. We'll do some input values, output values. This time I'm going to do -2, 0, and let's do 4, just for fun. So if I did an input value x equals -2, it'll give me a y value of -6. If I did an input value of 0, -4 plus 0 is -4. If I did an input value of 4, -4 plus 4 is 0. And then I could graph those 3 points. So I have -2, -6 way down here. I have 0 and 4 way up here. And I have 4. I have 0 and -4, sorry, right there. And then I have 4 and 0, which is over there. And you'll notice this still does create a linear pattern. The lines just kind of spread out. But it is doing exactly what we wanted. The line should look like that. And again, don't forget arrows. All right, we're going to rearrange one more. Maybe 2, we'll see. This is another hard one. Okay, so I have this equation. I want to get y by itself. This time there's a lot of things that need moving. There's a 3 that needs to move, the x that needs to move, and the 6 that needs to move. You're going to use opposite operations, but sometimes people don't know what to move first. So to decide on what to move first, you're going to remember our little phrase, bed mass. Bed mass was the order in which we calculated things. We're going to use bed mass in reverse to get rid of things. So if I want to know what I move first, I move any subtractions first. I don't have any subtractions. Then I'm going to move any additions first. I do have an addition. I have 6x plus 3y. So I need to move the 6x, whatever's being added, first. The way that I move 6x is by doing the opposite operation of addition. The opposite operation would be subtraction. So I'm going to subtract 6x from both sides. That's me showing my work, and then I reorganize my work. So 6x's will cancel on the left, and I'm left with just 3y equals 12 minus 6x. The red is me showing my work. The black is me reorganizing my work. Follow that pattern until you get y by itself. Y is still not by itself. It has a 3 attached to it. That 3 means 3 times y. Perfect. So we're going to divide the 3. The opposite of multiply is division. And when you divide everything. So I'm going to divide the 3y by 3. I'm going to divide the 12 by 3. I'm going to divide the 6x by 3. The red is me showing work. I then reorganize my work. 3y divided by 3, the 3's cancel each other. So I have y equals 12 divided by 3 is 4 minus. When you get a weird fraction like this, all you need to do is focus on the numbers. So 6 divided by 3 is 2, then the x just stays there. So this means I have y equals 4 minus 2x. Any questions about how we move that stuff around? Honestly, probably one of the most important skills coming out of this grade, in my opinion, is how to do algebra. Yeah, Brie.
So when we subtracted the 6x, why didn't we subtract the 6 from it?
Oh, great question. She's asking over here, we had 12 minus 6x. Why didn't we combine those two things, right? Why didn't we subtract the 6 from the 12? Good question. The way I like to explain it is x is a thing. I like food, so I describe it as food. So I pretend that x is cookies, right? So if I have 12 and then minus 6 cookies, I wouldn't have 6 cookies left over. I would still have 12 and then these 6 cookies on the sides. They're different things. The phrase that we use is like terms. So you can only subtract x from other x's. If this had been 12x minus 6x, now they're both like terms because they're both cookies in my opinion. And that would equal 6 cookies.
So 12 is like chocolate chip and then the 6 times. So you raise it in like
exactly. What you guys probably saw in Fox Run is they probably use algebra tiles. Did you see algebra tiles?
Yeah.
So this is like 12 little individual tiles, the little squares, and this is 6 of the long skinny ones. They're not like terms, so they can't subtract from each other. Joey. So using reverse bedmass is the exact same strategy you'll use all the way through grade 12. Why did we stop? Good question. Okay. She asked, why are we done? Like, why did we stop at this moment? The reason we've stopped is because y is completely by itself on one side of the equal sign. So I go until there's nothing around y, and then I stop. Joey. Like over here. Yeah. They can get rid of that too. So if you try to do that, the problem is what you do to one thing, you do to everything. So I divide these by 2, I have to divide y by 2 as well. And then y is not by itself anymore. Right? So that's kind of the trick to all these algebra questions. Like, when do we stop? Yeah.
Then how are you getting x?
Am I getting x? Oh, like how am I getting my input values?
Yeah.
I'm just choosing input values. The question would either give them to you or you would just get to pick them. You could technically get x by itself, but then you're putting your input by itself, which is kind of weird. We usually just standard is go y by itself. Output by itself, input, everything else. Awesome.